Hello there, Narek is here. I'm gonna solve today the third exercise of second session 2018 chemistry, which is related to electrochemistry. So let's start classification of metals. Spontaneous redox reactions occurring between a metal X and a metallic ion Y and 2 plus release chemical energy. In these reactions, the more active reactant acts as a reducing agent reductant. Document 1 represents the procedure and the result of an experiment realized in the laboratory. A copper strip Cu is immersed in a colorless solution of silver nitrate Ag plus and O3 minus. A deposit of silver Ag covers the strip and the solution turns to blue. So in this reaction, as you can see, there is something which is happening. The color is becoming blue. It means that we have Cu2 plus ions which are being formed, and the deposit of Ag on the strip, it means that Ag plus is being transformed to Ag solid. By referring to document 1, answer the following questions. The oxidation half reaction taking place is Cu, which is being transformed to Cu2 plus 2 electrons. Choose among the half reaction given below the one that corresponds to the reduction half reaction taking place. So in case I want to find out the half reduction reaction, I have to check an equation where I have Ag plus being transformed to Ag solid. So the first one is Ag, which is being transformed to Ag plus, so I'm gonna forget about this one. The second one is a convenient one. The third one is Ag2 plus. I do not have the ion Ag2 plus in this case, so I should forget about it. Even the last one, so it's the answer B. Indicate among the following metals, Cu and Ag, the one that is more active. The one which is being oxidized, which is going through an oxidation, is, of course, the active metal. In this case, you have Cu, which is being transformed to Cu2 plus, so the copper is actually more active. It is the anode of this. It will play the role of an anode. Document 2 represents the schema of the cell G AlCu in functioning, as well as the axis showing the increasing order of the tendency of Al and Cu metals to lose electrons. By referring to document 2, answer the following questions. Using the list given below, name the numbered parts 1, 3, 4 of the electrochemical cell. Now, before naming these parts, we have to check in this cell which part is the anode and which part is the cathode. Because once we know the anode, it will be aluminium. Once we know the cathode, it will be copper, simply because we have the axis which represents aluminium as a metal with a higher tendency to lose electrons. In order to find out which is the anode, which is the cathode of this cell, we have to check the orientation, the direction which the electrons are taking in order to circulate. So we have the electrons going from the anode towards the cathode. So the part which is on the left should be the anodic part. It will be aluminium. So the number 1 is aluminium. The number 4 will be copper, and 2, or number 3 actually, is the salt bridge. Now the remaining numbers 2 and 5, actually 2, it should be a solution containing Al3 plus, because Al is immersed in the solution containing Al3 plus. As for the number 5, it should be solution containing Cu2 plus. They didn't ask about these parts, but we can, of course, simply mentioning them. Aluminium strip, copper, salt bridge, okay. All right. Write the oxidation and the reduction half reaction that takes place at the electrode of the electrochemical cell G. So we have at the anode we have oxidation reaction, which is Al being transformed to Al3 plus plus 3 electrons, and the second one we have at the cathode, we have half reduction equation, which is Cu2 plus 2 electrons. It gives you Cu solid. So these are the half reaction equations of oxidation and reduction. The 2.3 question is, did you use the overall equation of this electrochemical cell? In order to find out the overall equation, you need to check the number of electrons. You need to have 3 electrons, 2 electrons. You do not have the same number of electrons, so you multiply this equation by 2 and this equation by 3 in order to have 6 and 6. So it will be 3Al, 3 plus, 6 electrons, 3, sorry, I'm gonna repeat it again. So we have 2, 2, 6, 3, 6, 3. So the overall equation, you should simply add these two equations. It will be 2Al plus 3Cu2 plus. It gives you 2Al3 plus 3Cu. This is the overall equation. Answer by true or false. Justify the true statements and correct the false ones. So we have the solution 5 contains copper, 2 ions, Cu2 plus. Of course, it's a true statement simply because we have the copper strip, which should be immersed in a solution containing Cu2 plus. Potassium K plus present in part 3 of the cell migrate towards solution 5. In this part, you should simply remind yourself that K plus will migrate towards a part where the positive charges are less. So in which part I do have positive charges being transformed to other types of solid atom, it's Cu2 plus 2 electrons, which gives you Cu. So it's in the right side where we have the copper of strip, a strip of copper. So Cu2 plus being transformed to Cu, the number of positive charges will decrease. That's why I need K plus migrating towards this part where we have the solution 5. So it's a true statement. During a reaction, the quantity of aluminium Al3 plus decreases. That is false, because when we have an oxidation at this aluminium strip, we have Al being transformed to Al3 plus, so it's increasing. That's why it's false. Classify the 3 metals Al, Ag, and Cu in an increasing order. So from document 1, we already find out that Cu is more active than Ag. In the second part, we know that Al is more active than Cu. So automatically Al is the most active, then Cu, and then Ag. So you simply make an axis with the tendency to lose electrons. The first one is Al, the second one is Cu, and the last one is Ag. Alright, this was the third exercise from second session 2018 chemistry. I hope it was helpful, so I'm gonna ask you to subscribe to my channel because I'll be uploading new material, I'll be solving new other sessions. I can also share with you my Instagram and Facebook account. You can contact me directly, or you can simply leave a comment below. That's all for this time, and see you later.